Okay, so today we are going to begin with arrays, and before giving you the definition of arrays, let me tell you what it actually means in plain English. It actually means a collection. It's a set. It's a collection. Exactly the same thing what you studied in mathematics called set, where even in set we had a kind of a collection. So here even arrays is similar to set, and here too we have a collection, and however the collection is always a set of data. So when it comes to defining an array, let me define it first. It is a set of homogeneous, I'll tell you the meaning of why this homogeneous data that occupies contiguous memory location. So when it comes to an array, we have a set of data which is homogeneous in nature. That means the data type of all data, or the entire collection, the data type of the entire collection is of same data type. Now what do I mean by that? Suppose we are going to create an array of numbers. When it comes to numbers, you see there may be floating point type also, as well as integer type also. This particular part you have already studied before. int, float, double, different type of data, even long, so many different type of data types are there. However, when it comes to an array, whenever you are creating an array, it should be of the same data type. That means you may have a collection of only integers, or you may have a collection of only floating point numbers, or you may have a collection of characters, that is alphabets, or any kind of symbol that may be included in the characters. I'll come across character arrays later, but first of all we are going to deal with only numeric type of data. That will be easier for us to understand or to manipulate arrays, because we are putting much stress on the usage of arrays and how do we manipulate data in it. Now the very first thing is, how do we define or declare an array? How do we declare an array? We declare it this way. Simply write int a of 5. This is the technique of declaring an array. Once you declare that, let's say for example I put a semicolon out here, int a of 5. That means you are creating a collection, or you are creating an array of integer type. And how many data you can store? You can store maximum 5 numbers over there. And all these 5 numbers are integers. So you can imagine it to be something like this. This is the collection. 1, 2, 3, 4, 5. So this entire collection has the name A. So A is the name of this entire collection. And how many spaces are there to store integers? There are 5 spaces. 1, 2, 3, 4, 5. So there are 5 spaces. Now this is the entire collection is created inside the computer's memory. Now what happens is, interestingly, each of these places you'll be able to store numbers, definitely. I will come across that later. However, what is more important is, these elements are stored in contiguous memory location. This is what I want to stress currently. Contiguous means one after the other. That means one beside the other. So each element or each item in this particular collection or array occupies contiguous memory location. That is one after the other. This is how the data is arranged in an array. Now something very interesting happens. For each of this data, there is a certain position. We call it index or subscript, which indicates the location of an element in the array. So say for example, this index is 0. Actually the index always begins from 0, at least in C++. 0, this is 1, this is 2, this is 3, this is 4. So what actually happens is, the entire collection has its first element subscript as 0. That means, what do I mean by that? Whatever integer you are going to store it over here has its position as 0. You can imagine it with this. Say for example, I am going to store these numbers 5, 12, 7, 19, 8. So the number 5 is stored at position 0 or has the subscript 0 or has the index as 0. I can tell it either way. So the number 7, obviously the index is 2. The number 8 is obviously stored at index 4. So this is how the entire index is numbered. And remember, we always write 5 indicating there are 5 elements over here. However, the index always begins from 0. It's always a whole number and ends at 4 because there are 5 elements. If you want to declare an array of size 100 where the index will start from 0 till 99, you can just go for int of 100. If you are going to declare a floating point array, so please write float instead of int. For a character type array, we'll write char, char. So instead of char or instead of int or float, you may write char over here. But we'll do character arrays slightly later. First of all, we'll stress on only numeric type of arrays. Now, the next thing is, how do we insert elements into this array? That means, in other words, how do you input data inside the array? So how do we do? One method of doing is very simple. After this is done, we can write it this way. Cin a of 0, a of 1. Note that the third bracket, that is the square bracket, is used to indicate the position where you are supposed to input the data. So a of 0, a of 1, a of 2, a of 3 and a of 4. So here you see the third bracket is also used to access individual elements inside the array. So when I write cin a of 0, that means you have the ability to enter a number inside the index 0. Say for example, if I input 5, so inside the memory something like this happens. Inside the memory at index 0, the number 5 gets stored. Similarly, inside the memory at index 1, the number 12 gets stored. Similarly, inside the memory at index 4, the number 8 gets stored. So this is how the entire thing goes on. So now, a weird question comes up. Say for example, if I ask you to declare an array of size 100, that means you are supposed to input 100 elements into the array. In that case, what do I do? If you write this, the entire page will get filled up by writing, from a of 0 till a of 99. And imagine if I ask you to declare an array of size 500 or 1000 perhaps. In that case, you will fill up the entire page just for doing the input. So this is not a practical method. Though we are able to do it, we are able to use it, but you cannot tell this is a practical method. So what we are going to do is, we are going to apply a much more practical method to this. So how do we do that? So instead of doing this, what we are going to do is, we are going to take a variable, say I. So now, you may take I, X, Y, Z, anything, it doesn't matter. Now, we are going to give a message to the user, enter 5 numbers. So after this message is given, now what I'm going to do, you can put endl out here, because you have to enter 5 numbers. So perhaps the input should start from the next line onwards. So for I equal to 0, I less than 5, I'll tell you the meaning of this, I plus plus, and then we'll begin with cin a of I. Cin a of I. So now you see something very interesting happens. What is the value of I initially? 0. So cin a of I means a of 0. A of 0 means exactly this. So this time I can enter a number over here. So, and that particular number will get stored at index 0. Similarly, when the value of I is 1, cin a of 1 will make me store the next number at index 1. Similarly, when I is 2, it will make me store the next number at index 2. So, successive numbers are stored. So, here you see, when I give 5, I am writing I is less than 5. That means this particular loop is going to range from 0 till 4. So, this is the much more, easier, or we can tell much more practical in nature, inputting inside the array. So we are going to use this particular technique instead of using the prior technique. Though we can use that particular technique, but this is perhaps a better method of doing it. Because when it comes to 100, elements, you don't need to write the entire thing. Simply you need to change this to 100. And that's it. The program still remains same, at least with respect to the size. Next, suppose the most interesting part, I just forgot to mention that, the most interesting part about arrays is, you see, prior to this arrays, even in class 7, you had learned how to input 10 numbers and do all kind of manipulations. Say for example, finding the sum of elements, finding the average. You learned a hell lot of programs, related to entering a collection of numbers. Now arrays, don't think that it will be much different from whatever you have learned over there. Except this time, when it comes to an array, the best part of an array is the data gets stored. That means in the sense that, you see, prior to this, what you used to do is, you used to use the same variable. Say for example, if I ask you, before using an array, you learned programming in class 7, where there were a lot of programs related to entering 10 numbers. So what you do, a particular, this type of problem is, you start with a for loop ranging from 0 till, less than 10 or 0 till 9, and then we used to write C in A. And all those numbers which you input used to come inside the variable A. So every time you give a value, the A will get replaced, or it will be replacing the value which was previously entered by the user. So what actually happens is, by the time you come to the 10th input, what happens? You only have the 10th number, whatever you have entered, it only remains in the memory. Whereas when it comes to an array, the best part of an array is all the numbers. Even if you enter the 10th number, what will happen is all the numbers prior to the inputting of the 10th number will still there in the computer's memory. So here you see, I have an array of size 5, and here what I am doing is I am inputting the first number in A of 0, the next number in A of 1, the next number in A of 2. So that means I am not using the same variable to input the numbers. So the resultant is what? Every number gets stored inside the computer's memory. So now when I start displaying, you see, a very interesting method of displaying is, for I equal to 0, I less than 5, I plus plus, and here what I do is I write C out A of I and end. What is happening? Initially the value of I is 0, C out A of 0. A of 0 means whatever number you have entered. If I enter inside A of 0 the number 5, so 5 will get displayed. Next time the value of I is 1, so A of 1 will get displayed. Had it been 12 entered by the user, it will display 12. So you see, all the 5 numbers, the way you have entered can be displayed. In fact, you will also be able to display it in reverse order. Say for example, we can simply do this. You begin the loop from 4, and this may be written as greater than equal to 0, I minus minus. That's it. So it will display the last number first. So it will display 8. The next time the value of I will be 3. So it will display 19. Next time the value of I will be 2. It will display 7. Like that, all the numbers, obviously in reverse order, can be displayed if you apply or use the loop in the reverse order. So this is how we use an array. Simple as that. Now, sometimes students get confused whether I can use only I. You see, you may use any variable. It doesn't matter. You may use I, you may use J, you may use X, you may use B. It doesn't matter. I and J are usually a convention. People using an array, they are quite used to using I and J. So that's the usual practice, but not necessary. But still, we'll be maintaining the convention. That is the first aspect. Next, there are students who ask me a certain question. They ask me, when I write C in A of I, so C in A of 0, since the value of I is 0. So when I display, or when I need to access the individual numbers, should I use the variable I, or I may use another variable? Obviously you can use another variable, it doesn't matter. What I mean is, you may have another variable, say J. You may use I for doing the input, while for output you may use J, it doesn't matter. So here what happens is, here it doesn't matter whether the variable is I or whether the variable is J. What matters is the content of I and J. The content of I and J cannot be anything else other than numbers from 0 to 4, because those are the index of an array of size 5. So here you are entering all the numbers from index 0 till index 4. However, when you display it, you are displaying from index 4 to index 0. You are using the variable j, but it hardly matters whether the same variable is being utilized or not. Of course, if you use the same variable, it's always a good thing. But please remember, we may use another variable also. So initially, what is the value of j? J is 4. So C out A of j is going to display exactly what we had done prior to this. That is, it's going to display 8. Next time the value of j is 3, it is going to display 19. Next time the value of j will be 2, it is going to display 7, and successive numbers will be displayed until we get 0. I believe you have understood this. Now what we are going to do is, I am going to make you solve a sample program first. So now what we are going to do is, I am going to make you solve a very simple program where what we need to do is, we need to input 10 numbers into an integer array and find their sum. Simple as that. Okay. You may be able to solve, but still, you see how I'm going to solve this particular question. So we'll begin with has include. Don't forget the header files. Now you can look at this program. Here I have written a question, write a program to input 10 numbers into an integer array and find their sum. So your program should begin with the header files as usual. Whatever you have learned in class 7, we'll be continuing with that. And here we begin with the statement clear screen. Obviously, I believe you understand what is the meaning of this. Then we declare an array. Declaring an array means telling the computer, please allocate 10 spaces so that I can store 10 integers into this memory space. So A of 10, the name of the array, I have named it as A. Remember, you can give any name, it doesn't matter. 10 is the size because the question tells that you have to input 10 numbers into an integer array. An integer array, that is why I have taken as int, and then I have taken a variable I, and then I have taken a variable s, which is initialized with 0. And here I give a message, enter 10 numbers, and this part is usual. I is initially 0, so C in A of 0. So the first number is entered inside A of 0. And what we are doing, we are finding the sum s equal to s plus A of 0. Next time the value of I is 1, so C in A of 1 is equal to s plus A of 1. So the next number gets added. So subsequent numbers get added over here, and ultimately after coming out of the loop, whatever is the sum, you are displaying it. So this is one aspect, no doubt regarding it. This is one way of doing it. However, I want you to do it in a slightly different way from now onwards when it comes to arrays. What we are going to do is, we are always going to keep the input separately, in the sense that we are going to use a separate loop for doing only the input. We are going to do nothing out there other than doing the input. Sum or whatever I ask you to do should be done in a separate loop. Why am I telling you? Although this is perfectly valid, this is because you will come across programs later on where we need to do, obviously, only this is the method of doing it. In that case, you will always, face a problem if you continuously, practice programming this way. So what we are going to do is, we are going to follow a convention where we'll have a loop which will only perform the input. So nothing else other than the input. So this particular loop will be having nothing else other than inputting 10 numbers. And don't worry, even if I come out of the loop, the numbers are already stored. I already said that. That's the benefit of using an array. We'll be using a separate loop to find the sum. So here I have a separate loop which is going to find the sum. And here I write that s equal to s plus A of I. I don't need to do the input once again because the input is already done and it gets stored inside the memory. So here we are going to display the sum. So sum equal to s. That's it. Simple. Now, I'll be giving you a few questions for you to solve. Please solve those questions and, upload the image of whatever solution you have done. Upload those images. I'm going to check it.